Right. And they're constantly pawing the edge because they can't see.
Oh, we're ready. We're going.
Let's fire it up again.
Okay. Do you want to call every? Yeah, we're calling. We're right now. We are recording. This is being reserved. So.
Do you want to holler at those guys to shut up or close the door or something or other? So we can treat this segment as a open discussion if you want. Feel free to chime in with your favorite embedded firmware idioms, but you tend to find some funny kinds of C constructs and a few tracks when you're programming embedded systems in C. So I thought it was maybe worth saying a few words about it. The first is the keyword volatile. Volatile tells the compiler that this memory location can change. And in general, in embedded systems, if you tell the give the compiler an instruction like read from this memory location, and often I/O ports are memory mapped, then go and read again because you're perhaps in a while loop looking for something to change. The compiler will optimize that, and it'll read it once from the port, and then like cache it in a register and keep checking, is it equal to, and of course the register never changes even though the I/O port does. So volatile defeats that behavior of the compiler when you turn optimization on. This is a construct that some people have looked at me sideways and said, what in the heck does this mean? But you find it a lot in embedded programming where you need to set a particular bit. So let's take it apart. Port B is a byte-sized register, equals, long vertical mark equals, means the same as port B equals port B or bitwise ORed with whatever value you give it. So it's just ORing in the right side of the equation is what that expression does. The right side of the equation, one left shift PB3, means move one left the number of bits, the number of positions indicated by PB3. And really the intent of this expression is self-documented code. You could just, so PB3 happens to be 8, right?
Port B bit 3.
Yeah, right. So 0, 1, 2, so it has a value of 8. So you could write this.
No, 3. No, 3.
But one shifted left 3 times is 8.
Yeah, right. So if you were looking at an 8-bit register and you wanted to set bit 3, you would add 8 to the value of the 3-bit register.
Or you add 8 if you knew that the value was 0.
But that's just actually a left shift 3 times.
Yes, that's right.
And that symbol is predefined by the compiler, PB3, for the AVR chip.
As being 3, presumably, right?
Yes, it's in a header file.
And I think the main, so it's a weird looking expression, but you see this a lot in embedded code. You also see some value right shift by some number of bits. But I look at this as being a documentation aid, clarity of expression, rather than ORing in 8, because magic numbers are bad. You don't want to use magic numbers.
Well, even more clear would be to use the next idiom, which is a pound define. You could have a pound define that encapsulated the name of what that, like you could say sensor, left sensor, right sensor, and use that. Yeah, that would be even.
That's right. And the converse. So this sets a bit, the bit 3. The converse is and equals, which is the same as equals port B and not this. So not one left shifted 2 bits would be the complement of 4, which is going to be...
It's toggling all the bits. Not
right,
would be
toggles all the bits, so it turns it into FB.
But that's not the same as the not. There is a exclamation point that would be the not operator.
That's a
You could do
logical.
that.
That's a logical knot.
Right.
Be careful of the difference
Bitwise.
between a
Right.
logical
That's what I'm
knot
saying.
and
That's why I
a
hate to call this a
bitwise
knot,
knot.
because it's
Yeah.
really just flipping all the bits.
this is the
Inverse.
bitwise inverse, so it
Yeah.
complements all the bits. The complement of all the bits of 0 hex 4 is 0 hex FB, I believe. And then the other note along the documentation line is use meaningful, recommended to use meaningful names or caps instead of magic numbers buried deep in your program. And I will admit that I'm not very good at that always, but that's good practice.
The other good note about that second line is it doesn't require any multiplication on the part of the processor.
Thank you. I'm glad you mentioned that. I meant
Very
to bring that up. Yes, the processor does not multiply. Does not even need to know about fractional about floats. It will or it pre-computes the value at compile time and compiles it down into a constant. So who else has like favorite embedded idioms?
I can give you a little bit of context on the second line, the setting and resetting bits, because you're going to do that all day long in embedded programming. You're talking to the hardware directly.
It's not just embedded, it's pretty much any compiler at all will do the same.
Sure, but you run into the need to manipulate bits in embedded programming.
I'm not talking specifically that operation.
No, that is portable code, and that's why that is now what is being encouraged. To me, it's unfortunate because I don't use it enough in that format to recognize it when I see it, and I would have to think about it. Do I want to AND it? Do I want to OR it? Do I want to, AND it with the complement, or was it OR it with the, it doesn't say what it means and means what it says. So originally, in the earlier versions of the GCC port of the AVR, or the AVR port of the GCC toolchain, they actually had some macros that corresponded to the assembly language instructions for set bit and clear bit. Those are actually machine language instructions. They will set and clear bits in the I/O space, just given a bit number. And they're very fast. They're a read, modify, write operation that happens in 2 cycles.
The set bit and clear bit on the ones, the AVRs that I've played with, are single cycle and they get only the 1 bit. There's no read, modify, write.
Yeah, Carl said that this compiles down into a set bit or clear bit instruction. Apparently.
Which is 2 cycles.
Depends upon
I got $1 that says it's 2 cycles. So you can check that.
Let's take a look, because
we have $1 on the table here.
I got $1.
$1 on the table. All
So,
right.
so but it's because it's a read, modify, write.
Okay.
It's a bitwise instruction, and that was the key thing about it.
It is.
I mean,
Okay, let's not
No, you're right.
Let's not get.
Well,
Let's not
but
pull up a level.
Take 1 or 2 blocks.
But the point was
That's
that
a very
you
cool
could
file.
use what it turned into, and it was called SBI for set bit and IO register, and CBI for clear bit and IO register, and they made a C function out of each of those. So there was an SBI open close parentheses function that you would give the parameters, the port and the bit, which worked great. But as many people and authorities pointed out correctly, it's non-portable code. The nice thing about the macros were the actual instructions are limited on what addresses it will actually work on. So if it was within the ones that could be implemented with a single instruction, it would. If it wasn't, it would implement the read into a register, generate a mask, do everything that you needed, whether it was a memory location or an I/O register. And people got used to using those. But like I said, it was pointed out, not portable, not good.
This isn't really portable to other hardware either. I mean, you have to
outside the hardware, no, but code-wise,
you have to have an AVR chip to make use of that line.
But
No,
this is
no,
because you
it
can
could be
use
any
this
chip.
for setting individual bits
Yeah, but
in
it'd be
memory.
a different bit and a different. I mean,
No,
that's what.
well,
With
right,
this much
but that's the
documentation, you
Compiler's
can't tell
job
what's
is to
going
do
on.
that. That's-
With this much, what you have written on the second line doesn't really tell you what the purpose of this was. If you'd gone farther and said, okay, I have a pound define for the shift, instead of port B, I say what port B is with a different pound define, then it might be a little bit.
But
portable.
it's somewhat
Within the
better than
context.
plus equals 8.
Yeah,
is
it's
really the
plus
only
equals
point
8.
I'm making.
right. But
Okay.
it is that's the they've deprecated those functions out of the library, the CBI and SBI functions. They say, don't do that, it's not, you know, it's not the right thing to do. I still use it. I have my own macros that do that. And the compiler is smart enough to know when that instruction is appropriate. It will actually put that instruction in when it can get away with the single instruction that does that. But an even better way and a better documented way, which is still non-portable, is to use bit fields within a structure and say, well, this, you know, I'm going to define each individual I/O pin as its own bit field, and that way, all I have to, once I've got that declared, I can just say port B dot PB0 equals 1 or 0. I don't have to do any shifting left or right. The compiler does all that for me.
And I
Not
think
portable at all.
I think if I remember correctly, the syntax is something like this, right? It's like struct foo A:3.
With a bit
You
length,
need a
yeah.
type in front, don't you?
Right.
No, no, only if you're declaring it as a type. You don't have to declare it as a type.
And that's generally
Look it up
works,
in
but
the-
it might be buggy.
Look it up in the C manual. It's generally considered non-portable
It is not
because
portable.
it's compiler
Well,
dependent.
I think the other reason they depreciate all this stuff is I took an X-Mega class from AVR, and a lot of the syntax in the Mega and the Tiny breaks when you go to the X-Mega chips.
I would
So
doubt
they're trying to clean it up where it works across all the
Okay, so-
AVR 32s and everything else.
So I think the main thing that I wanted to share with you guys is how to implement state machines in software or in firmware. Because why would you want to implement state machines? Well, mainly because it gives you a way of doing multiple independent things simultaneously.